All right, so what we're going to talk about now is neurons. So we're going to go through this, and if I'm going too quickly, feel free to slow the video down or pause at different spots. So remember, neurons help us to move. They help us to feel. It sends signals all throughout our body. So what we're going to do is we're going to focus on the different parts right now. So to start, we're going to do our neuron dance, and I highly recommend that you do this each and every time. You wave your dendrites. Those are going to be the receivers. You're catching something with that. Nod your soma, it's your head. The nucleus is inside there. It's essentially the thing that sends signals to the rest of the body. The axon is what you're going to shake. So when you shake your axon, that is essentially what is happening there. So I just want to make sure it's going. And then your axon terminals or your terminal branches are going to throw neurotransmitters. So it's going to be tossed or thrown out. So wave your dendrite, you're going to receive with that. Nod your soma, nucleus, cell body, shake your axon, that's where the message is being sent, and terminal branches. But if we wrap myelin around that, that is going to make it all go faster. Where you're dendrite, nod your soma, shake your axon, terminal branch, it's going to make it go a lot faster and more efficiently. The more we do things, the more myelin we have wrapped around. So again, dendrites are these finger-like things that receive. Your soma is the cell body. And the axon is that long, skinny piece with the yellow being the myelin sheath wrapped around it. Then the terminal branches are going to be the ends that are going to send out neurotransmitters into what we would call the synapse. And so if we looked at these two neurons, we're the presynaptic and postsynaptic. The presynaptic neuron has the synapse right in between here, and that's where neurotransmitters like dopamine, serotonin, norepinephrine are sent through this space called the synapse. Remember, when this information is going from the soma to the rest of the neuron through the axon, it is an electrical impulse that essentially bounces its way through. It's electrical. Then the neurotransmitters are chemicals that are sent between the neurons. So I'd like you to draw two neurons if you need help with that and practice filling that out. So now talking about how neurons essentially function, we're going to talk about it in terms of it related to a toilet. So remember, when the neuron fires, it fires an electrical impulse from left to right. So the first thing is the action potential. This is the information that's sent from the soma down the axon. So the action potential is when you flush the toilet, it is the water flushing through the pipes, sending that signal on. All right. So that's the action potential. It's the actual electrical message. The refractory period is, think about an electric factory. The refractory period is when the toilet won't flush again because it's refilling. So now the action potential has been sent. It needs to essentially sort of recharge itself. The electric can't send again. So refractory, the electric factory. The next is reuptake. So after neurotransmitters are sent from top to bottom, they're latched into these receptors. They need to go home. Think about them going up and home. They're going again, being reabsorbed, reuptake. So this is kind of like the inside of the bowl being filled back up so the toilet can flush everything again. The neurotransmitters are essentially anything you put into the toilet, and then they're going to be flushed back home, all right? So reuptake is when the chemicals, the neurotransmitters, are pulled back. The last two are the absolute threshold, which is the minimum amount of stimulus for the neuron to fire the electrical impulse. So once it hits a certain point, we won't get into the specific numbers, the neuron is either going to fire or not fire. Similar with a toilet, you can flip that knob very lightly, the handle, but if you don't push it hard enough, it won't flush. So you can put pressure on it, but it needs to get to a certain point for it to actually send the message and flush. This is what we call the absolute threshold, the minimum amount of stimulation required to, boom, send that neuron's action potential. Lastly, we have the all or none response. Just like a toilet, you either flush it or you don't. If it doesn't send the signal, then it won't send it at all. It doesn't send a half a signal or a quarter signal. It is either all or nothing. It just sends it or it doesn't send at all. So jumping into the neurotransmitters really quickly, just to have something else for you guys to reference. The neurotransmitters that we're going to talk about are right here: agonists, antagonists, acetylcholine, dopamine, serotonin, norepinephrine, and endorphins. So for dopamine, for acetylcholine, this is your memory and muscle movements. When I move or I remember things, that is acetylcholine. An undersupply of this can lead to Alzheimer's. Dopamine is like a pleasure neurotransmitter. When you essentially get a reward for something, you feel really good. That's dopamine being sent throughout your brain. Too much of it, you can see here, can cause schizophrenia. So if there's too much dope in the halls, hallucinations, you might develop schizophrenia. Not enough dope in the Parkinson's disease. It's when people have tremors and other sort of side effects. So the next one is serotonin. So think about antidepressants work. And so Sarah is happy, not sad, or Sarah is not happy, she's sad. We want to level out their mood. So serotonin is the mood neurotransmitter. The last two, norepinephrine. Nora likes to fight and take flights. And so norepinephrine is when you essentially fight or flight kicks in to fight or run away. And so this sends essentially the signal to send adrenaline throughout your body. And lastly, endorphins. Endorphins are released in response to pain. And so essentially, when you get really injured, you might not feel it quite as much because your endorphins are being rushed through your body. That runner's high that you might get is also related to endorphins. So that's where working out can relieve stress. So endorphins can relieve stress as well. Last thing, agonist versus antagonist. Agonist mimics. So remember we talk about that the agonist essentially mimics what happens. The antagonist blocks it. So the agonist is going to act like the neurotransmitter that's supposed to be being sent, so it can add more energy to it. The antagonist is going to block the neurotransmitter from getting in, so you're lacking that specific neurotransmitter. All right, I hope that helped. Feel free to reference any of the other materials. I know I was very quick, but I'd love for you guys to stop and pause that whenever you need help, and then look at all of the different mnemonic devices. I know they'll help you out. Let me know how I can help you out.